Download this code from codegive.com, link in the description below. Mastering Contrast and Clarity in Image Processing, a comprehensive tutorial. Contrast and clarity are fundamental image processing techniques used to enhance visual appeal, improve feature visibility, and ultimately, make images more informative. They are often applied together to create images that pop and reveal details that might otherwise be obscured. This tutorial will delve deep into the concepts of contrast and clarity, their differences, common methods for their adjustment, and practical implementations using Python and the popular image processing library, opencv. 1. Understanding contrast and clarity ****. Contrast ***. Definition ***. Contrast refers to the difference in luminance or color that makes an object distinguishable. It's the range between the darkest and brightest areas in an image. Impact High contrast images have stark differences between light and dark areas, leading to a visually dramatic and often sharper appearance. Low contrast images have a narrow range of luminance values, resulting in a muted, washed-out look. Perception High contrast can make details more apparent in the brightest and darkest areas. However, extreme contrast can lead to loss of detail in these regions due to clipping, values being pushed beyond the representable range. Low contrast can make it difficult to discern fine details, even if they are present in the underlying data. Examples A photograph of a black cat against a white snowdrift has high contrast. A faded photograph of a gray object against a similarly gray background has low contrast. Clarity Definition Clarity, also sometimes referred to as local contrast, enhances the perception of local detail within an image. It emphasizes fine structures and textures by increasing the contrast between adjacent pixels. Mechanism Clarity algorithms typically analyze local neighborhoods of pixels and adjust the contrast within those regions, often based on edge detection or unsharp masking techniques. Impact Increasing clarity makes images appear sharper and more defined, revealing details that might be hidden by overall low contrast or blur. Decreasing clarity softens the image, reducing the prominence of fine details and potentially creating a more dreamlike or ethereal effect. Relationship to sharpness Clarity and sharpness are closely related, but not identical. Sharpness typically involves enhancing high-frequency components in the image, example using unsharp masking with a small radius, while clarity often operates on a slightly larger scale, focusing on enhancing mid-frequency details and textures. Sharpness can sometimes amplify noise, whereas clarity can be implemented to be more robust to noise. Examples Increasing clarity on a landscape photograph can bring out the details in rocks, trees, and clouds. Decreasing clarity on a portrait can soften skin and reduce the appearance of blemishes. 2. Methods for adjusting contrast Here's a breakdown of common contrast adjustment techniques. A. Linear contrast stretching, normalization. Concept linearly maps the pixel values from the original range to a new, wider range. This is one of the simplest methods and can be effective if the image data isn't using the full available range. Formula where old_pixel_ value is the original pixel value. min_value and max_value are the minimum and maximum pixel values in the original image. new_min_value and new_max_value are the desired minimum and maximum values in the output image, usually 0 and 255 for 8-bit images. Code example, Python with opencv. Asterisk pros asterisk simple, fast to compute. Asterisk cons asterisk ineffective if the image already uses the full range of pixel values, or if the problem is uneven lighting, some areas too dark, some too bright. Sensitive to outliers, very bright or very dark pixels can throw off the mapping. Asterisk B, histogram equalization asterisk. Asterisk concept asterisk redistributes the pixel values to produce a more uniform histogram. This effectively stretches the contrast in areas where pixel values are clustered. It's a nonlinear method. Asterisk algorithm asterisk it involves calculating the cumulative distribution function, CDF, of the image's histogram and then mapping pixel values based on the CDF. Asterisk types asterisk. Asterisk global histogram equalization asterisk applies the equalization to the entire image. Can be effective for increasing overall contrast but can sometimes over-enhance noise or unwanted artifacts. Asterisk contrast limited adaptive histogram equalization, CLAHI divides the image into small tiles and applies histogram equalization to each tile separately. A contrast limit is applied to prevent excessive amplification of noise. CLAHI is generally preferred because it's more robust and produces more natural-looking results. Asterisk code example, Python with opencv. Asterisk pros asterisk effective for enhancing contrast in images with poorly distributed pixel values. CLAHI is generally robust and produces good results. Asterisk cons asterisk global histogram equalization can sometimes introduce artifacts or amplify noise. CLAHI has parameters that need tuning, clip limit and tile size. Asterisk C, gamma correction, power law transformation. Asterisk concept asterisk adjusts the pixel values according to a power law relationship. Gamma correction can lighten or darken midtones in the image, affecting the perceived contrast. Asterisk formula asterisk. Where asterisk old underscore pixel underscore value is the original pixel value, normalized to the range 0 to 1. Asterisk gamma is the gamma value. Gamma 1 brightens the image, gamma 1 darkens the image. Gamma equals 1 results in no change. Asterisk code example, Python with opencv. Asterisk pros asterisk simple to implement. Can effectively brighten or darken images and adjust the perceived contrast. Asterisk cons asterisk doesn't adapt to local variations in contrast. Can sometimes introduce artifacts if the gamma value is too extreme. Asterisk D, contrast enhancement with bitwise operations asterisk. Asterisk concept asterisk contrast enhancement with bitwise operations works best on grayscale images. It manipulates the bits representing the pixel values to either increase or decrease the difference between adjacent pixel values, thereby affecting the contrast. Asterisk process asterisk the basic idea is to use bitwise AND, OR, and XOR operations with a carefully chosen mask to amplify the differences between darker and lighter regions. The specific operation and mask values depend on the characteristics of the image and the desired effect. This method is often used when traditional contrast methods overemphasize noise or lose subtle details. Asterisk code example, Python with opencv. Asterisk pros asterisk can selectively enhance or suppress contrast in specific regions of an image. Asterisk cons asterisk requires careful selection of bitwise operations and mask values. The optimal choice depends on the characteristics of the image and can be difficult to automate. May be more suitable for specialized image processing tasks. Asterisk E, manual contrast and brightness adjustment. Asterisk concept asterisk this method allows for direct control over both contrast and brightness by applying a linear transformation to each pixel value. This approach is more intuitive as it lets you adjust brightness and contrast independently. Asterisk formula asterisk. where asterisk old underscore pixel underscore value is the original pixel value. Asterisk alpha is the contrast control, alpha, where values greater than 1 increase the contrast, and values less than 1 decrease the contrast. Asterisk beta is the brightness control, beta, which adds a constant value to each pixel, increasing the overall brightness of the image. Asterisk code example, Python with opencv. Asterisk pros asterisk. Asterisk simple and intuitive adjustments. Asterisk separately adjustable contrast and brightness. Asterisk can be easily implemented using cv2.convert scale ABS. Asterisk cons asterisk. Asterisk may require manual experimentation to find the optimal values for alpha and beta. Asterisk does not adapt to local variations within the image. 3. Methods for adjusting clarity asterisk asterisk. Several methods can be used to adjust clarity. Asterisk A, unsharp masking asterisk. Asterisk concept asterisk enhances edges and details by subtracting a blurred version of the image from the original. This effectively amplifies high-frequency components, making the image appear sharper. Asterisk algorithm asterisk. 1. Blur the image using a Gaussian filter. 2. Subtract the blurred image from the original image, this creates a detail layer. 3. Add a weighted version of the detail layer back to the original image. Asterisk formula asterisk. Where asterisk amount controls the strength of the sharpening effect. Higher values result in more sharpening. Asterisk code example, Python with opencv. Asterisk pros asterisk effective for enhancing details and making images appear sharper. Asterisk cons asterisk can amplify noise if the amount parameter is too high. Can create halos around sharp edges. Asterisk B, bilateral filter, noise-aware smoothing. Asterisk concept asterisk smooths the image while preserving edges. It takes into account both the spatial proximity of pixels and the similarity in their intensity values. This is excellent for removing noise while keeping edges sharp. Applying this can sometimes increase perceived clarity. Asterisk algorithm asterisk the bilateral filter calculates a weighted average of pixels in a neighborhood, similar to a Gaussian blur. However, the weights are determined by 2 factors. 1. Spatial proximity asterisk pixels closer to the center of the neighborhood have higher weights, like a Gaussian filter. 2. Intensity similarity asterisk pixels with intensity values similar to the center pixel have higher weights. This is crucial for edge preservation. Asterisk code example, Python with opencv. Asterisk pros asterisk excellent for noise reduction while preserving edges. Can subtly enhance perceived clarity. Asterisk cons asterisk computationally expensive, especially for large kernel sizes. Parameter tuning is important, especially sigma underscore color. Asterisk C, local Laplacian filter asterisk. Asterisk concept asterisk a sophisticated technique that selectively enhances details based on local Laplacian pyramids. It decomposes the image into different frequency bands, scales, and then applies different gains to each band. This allows for fine-grained control over detail enhancement and can effectively boost clarity without introducing excessive artifacts. Asterisk complexity asterisk requires careful implementation and parameter tuning. Not a standard opencv function. However, you can find implementations online and adapt them. 4. Considerations for color images asterisk asterisk. Asterisk color spaces asterisk when working with color images, it's crucial to consider the color space. Common color spaces include asterisk RGB, red, green, blue. The most common color space for digital images. Asterisk HSV, hue, saturation, value separates color into hue, color type, saturation, color intensity, and value, brightness. Adjusting the value component can be useful for contrast manipulation without affecting the color itself. Lab, luminance, A, B separates color into luminance, brightness, and two chromaticity components, A and B. This color space is designed to be perceptually uniform, meaning that equal changes in color values correspond to roughly equal changes in perceived color. Adjusting the luminance, L, component is ideal for contrast manipulation. Applying contrast and clarity to color images. For simple contrast adjustments, you can often apply the same techniques to each color channel, R, G, B, in the RGB color space. For more sophisticated contrast and clarity adjustments, it's often better to convert the image to HSV or lab color space, adjust the V, value, or L, luminance, channel, and then convert the image back to RGB. This avoids introducing unwanted color shifts. 5. Practical considerations and tips. Experimentation. The best way to learn about contrast and clarity adjustment is to experiment with different methods and parameters. Start with small adjustments and gradually increase the strength of the effect until you achieve the desired result. Image histograms. Analyze the image histogram before applying contrast adjustment techniques. This can help you identify problems such as underexposure, overexposure, or low contrast. Clipping. Be careful to avoid clipping pixel values, i.e., pushing values beyond the representable range. Clipping can result in loss of detail in the brightest and darkest areas of the image. Techniques like CLAHI often have built-in mechanisms to limit contrast amplification and prevent clipping. Noise. Some contrast and clarity adjustment techniques can amplify noise. If you are working with noisy images, consider applying noise reduction techniques, example Gaussian blur, bilateral filter, before applying contrast enhancement. Purpose. Consider the purpose of the image. Images intended for artistic expression might benefit from more dramatic contrast and clarity adjustments, while images used for scientific or medical imaging might require more subtle and careful adjustments to avoid introducing artifacts. Non-destructive editing. When possible, use image editing software that supports non-destructive editing. This allows you to experiment with different adjustments without permanently altering the original image. 6. Putting it all together, a real-world example. Let's consider a common scenario, enhancing a poorly exposed, low-contrast photograph. Explanation. One color space conversion. Converts the image to lab color space. The L channel represents luminance, which is where we'll focus our contrast enhancement. Lab is preferred because it separates luminance from color information. 2. CLAHI. Applies CLAHI to the L channel. This enhances the contrast locally without over-amplifying noise. 3. Merging channels. Merges the enhanced L channel with the original A and B channels to reconstruct the lab image. 4. Back to BGR. Converts the image back to the BGR, blue, green, red, color space for display. 5. Unsharp masking. Optional. Applies unsharp masking for a final touch of sharpness. This example demonstrates how to combine different techniques to achieve a more comprehensive and effective image enhancement result. The specific parameters, clip limit, tile size, unsharp masking amount, can be adjusted based on the specific characteristics of the image. Conclusion. Contrast and clarity adjustment are powerful tools for enhancing images. By understanding the concepts and techniques discussed in this tutorial, you can significantly improve the visual appeal and information content of your images. Remember to experiment, analyze your results, and adapt your approach based on the specific needs of each image. Mastering these techniques will give you a significant advantage in a wide range of image processing applications.